Hello there. Welcome to step 4 in the Glio toolkit, segmentation of glial cells. So far, we have looked at the images using the 3D viewer, split the channels, and have cropped and oriented the images so that we can now analyze each image and compare measurements. We can now move on to segmentation of the glial cells. This is performed by binarizing each image. Creating an image with only black and white allows us to delineate cell morphology from the background and create an outline of the Miloglia, which will help us in the next stage of image analysis. But before we delve into how to carry out this step, let's first discuss the challenges of segmentation. So the first challenge is the complex morphology of Miloglia, as demonstrated in our previous screencasts. To understand this, first imagine we're trying to look at a spherical shaped cell. Now we know the cell is spherical, so we know the cross-section will be a circle. Now let's take the example of a Miloglia. Unlike the sphere, the shape of a miloglial cell is unpredictable, especially the morphology of the end feet. It is our job to find out where these end feet are projecting. We do this by looking at the signal intensity in adjacent voxels in all three axes. For instance, in this end foot process, we know the process ends here, because all the adjacent voxels have an intensity value of 0. However, this only works in an ideal world. Now this is the same end foot process, but is a more realistic depiction of what we would encounter. Towards the end of the end foot, the processes become thinner and have a smaller surface area of membrane or volume of cytosol. This results in voxels towards the edge of the end foot process having smaller intensity values, shown here in lighter shades, thereby producing a gradient between the Miloglia itself and the background. The question then arises, okay, but what threshold do we use? If we include all the lighter shade voxels, we risk including artifacts within our data and overestimating the length and volume of miloglial cells. If we instead only include the black voxels, although we're more likely to exclude this artifact, we run the risk of underestimating the length and volume of miloglial processes. Hence the major challenge here is determining what shades to include within our measurements. Another challenge that is important to discuss is the way in which the fluorescent protein is administered. We tend to use transgenic zebrafish lines, with the fluorescent protein being expressed on the membrane, or in the cytosol. It should be noted that gliomorph can be used for immunohistochemistry, but extra processing in the macro should be considered due to the incomplete penetrance of the tissue by the antibody and the increased background signal due to an unbound antibody. Our final major challenge was the reducing data quality of layers within the tissue itself. Due to decreased penetrance of the laser to the inner layers of tissue, these layers often have poorer data quality. One of the ways in which we try to tackle this issue was by using Z-axis bleach correction, a tool that restores the data quality to these inner layers. So now we've discussed why this step is important and the challenges involved in this step, we will now discuss manual testing of the segmentation process. The purpose of this step is to visually assess the binarization process, to ensure we pick the best method of glial cell segmentation. To do this, we have created a macro that allows us to test 6 commonly used segmentation workflows. These are 3D simple segmentation, hysteresis, OTSU, moments, percentile, and maximum entropy. So moving on to the macro itself. To run this macro, open the folder gliomorph, then alternative macros, then alternative segmentation macros, and drag and drop the segmentation.igm folder into VG. You should have this screen. Once you have this screen, press run, and now it's time to choose the input files. So if there were single channel images, this would be ZDIR, as we have here. For multi-channel images, this would be the respective folder 1C, 2C, 3C, 4C within the ZDIR folder. And if you perform deconvolution, you should see a folder called deconv.dir. So if we press select, the macro is now running. And so the macro is now finished, and we can close this can now open up our file. In a folder called Segmentation Testing. And here we have all the segmented TIFF images.
And so I've opened up the 6 segmentation workflows, and I've picked the best and the worst examples from them. In order to choose which is best, we look at the delineation of the cell bodies of the Miloglia from each other. For instance, we can delineate cell bodies in this example, whereas on the right, it's a bit more difficult. We also look at the smoothness of the membrane of the Miloglia. So over here, the membranes are quite smooth, whereas on the right, they're quite rough. And we also look at whether the inner plexiform layer protrusions can be identified. So on the left, you can see these spicules, whereas on the right, they're a bit more difficult to identify.
Once you have decided the segmentation workflow, you can now perform segmentation on the glial cells, which will then be used for analysis. So to do this, we have 2 main segmentation approaches which can be found here. So if we go into gliomorph main, alternative macros, alternative segmentation macros, you should see cytosol segmentation and membrane segmentation. The former, as suggested by the name, is preferentially used for visualizing cytosol, whilst the latter is designed for visualizing the membrane. For this example, we use the cytosol segmentation macro. Now further on down the macro, you'll see something here called OTSU. We can change that depending on which segmentation workflow works best for yourself. And when you've made any relevant modifications, press Run. Again, we'll go to our input file, which in this case will be ZDIR if you applied the subregion tool to the AeroScan data. If you perform deconvolution, then use either ZDIR or deconv.dir, depending on which you performed last. So if we press select, and the macro is now running. The macro has now finished, so I'll close this down. And if I look in the file, I should have segmented TIFF images. Thank you very much for listening.